Hey guys, Dr. Brown here, and tonight we're working on a differentiation problem for you Calculus 1 folks. Recall in a previous video we had integrated 1 over x squared minus x plus 1 and ended up with what's in this parentheses, this 2 square root 3 over 3 tangent inverse 2 square root 3 over 3 times the parentheses x minus 1 half. But now we're going to differentiate, take the derivative of this, and see if we can end up getting what our original integral was. So hey, let's get busy. All right, to start with, I think I'm going to get rid of the fractions. I'm going to take this 2 and multiply it to the inside. So that would give me 2x, and 2 times 1 half would be 1. Okay, so I'm going to do that first. Now you know from the constant multiple rule, if we have ax to the n and we're taking the derivative of that, we can move that constant to the outside. We can say that's a times the derivative of x to the n. Well, that's what we're going to do here. We're going to take this 2 square root 3 over 3, move it to the outside. The other thing we need to realize, if we have tangent inverse of something, so we have a lot of things in this parentheses right here, tangent inverse of all of this stuff, that's my stuff in that parentheses, okay, that equals theta. Well, let's just challenge ourselves with that. Let's see, if I have 1 square root 3 over 2, and that's theta. Okay, I could say sine theta is opposite over hypotenuse. Sine theta equals 1 half. Okay, you can grab your calculator if you want to challenge me here. But if I want to know the angle, sine inverse of 1 half equals the angle. So put in sine inverse 1 half and you'll get pi over 6 or 30 degrees. So if you're in radians, you'll get to pi over 6. If you're in degrees, you'll get 30 degrees. Or if I said tangent, in our case, tangent inverse of 1 over square root 3, it's still going to give me 30 degrees. So I have that situation here. Theta, tangent inverse of everything in the box is theta. Okay, if I'm taking the derivative of that, I'm taking the derivative of all of this, right? So d theta would be the derivative, I'll do it like this, of all of that. Okay. So one might say, well, hey, how do you take the derivative of tangent inverse? Well, if I have, get a better marker here. If I have tangent inverse of something, just like I had earlier, let me redraw that. I have 30 degrees, so that's 1 square root 3, 2. Okay, if I had tangent of 30 degrees, that equals 1 over square root 3. So the opposite over adjacent. But in our case, we have tangent inverse of 1 over square root 3 equals theta. That equals 30 degrees. Okay, that implies that tangent of theta equals 1 over square root 3. It implies this. Now I can take the derivative of that. Derivative of tangent theta is secant squared, right? Okay, that's our plan for this. Now what does that look like? Well, if I have this angle, theta, it equals square root 3 times 2x minus 1 over 3. Opposite over adjacent. Now what does that mean for my here? If I take this and square it, square root of 3 squared is 3. So I'll put 3 times 2x minus 1 squared plus 3 squared, which is 9. Okay, that's the triangle and the angle that's represented by this. All right, so like I said, this is going to be 2 square root 3 over 3 times the derivative of what? All of this is theta. So I'm going to take the derivative of theta. So that's my constant multiple rule. I moved the constant out, and now I'm taking the derivative of theta. All right, so let's take tangent theta equals square root 3 over 3 2x minus 1. Okay, the opposite over adjacent. Now, the derivative of tangent theta, as I just mentioned, was secant squared theta d theta. Now, constant multiple rule, square root of 3 over 3 times the derivative of 2x minus 1. So the derivative of 2x, and this goes into the sum difference rule, okay? I can take the derivative of this and the derivative of that. So the derivative of 2x is 2 minus the derivative of a constant. That's the constant derivative of a constant rule, all kinds of rules. Derivative of a constant 0, so that goes away. All right, so d theta then is 2, I'll bring this 2 over, 2 square root 3 over 3 divided by secant squared theta. But secant squared is what? 1 over secant is cosine, so I have cosine squared. All over 3. Well, you may be thinking, but not yet. Okay, cosine of that angle theta is the adjacent divided by the hypotenuse. So I have d theta equals 2 over 2 square root 3, almost lost it there, didn't I? Over 3 times what? Cosine is 3 over that. So 3 over square root of 3 2x minus 1 squared plus 9. And all of that, that's cosine, but it's cosine squared. So I'll do that. Okay, so d theta is 2 square root 3 over 3. 3 squared is 9. This square root, what's our rule? Remember, a to the m times a to the n is a to the m plus n. I have something to the 1/2 times the same something to the 1/2. So the 1/2 plus 1/2 gives me 1, so the radical sign drops away. So I end up with 3 times 2x minus 1 squared plus 9. Okay, we need to move. Hopefully I don't run out of cord here. All right, 9 divided by 3 is 3. So 3 times 2 is 6. We're going to move up here. So that's 6 square root 3 over 3 times 2x minus 1 squared plus 9. I'm going to factor a 3 out of this because this 3 is just multiplied times this first one, not to the second one. So 6 square root 3 over 3 times what? Times 2x minus 1 squared plus 3. So now 6 over 3 is 2, so 2 square root 3 over 2x minus 1 squared plus 3. What is that? That's d theta, right? So d theta. So here we are way over here. All right, so that is what I need to plug in for d theta. So let's do that. All right, so I have 2 square root 3 over 3 times d theta, which is 2 square root 3 over 2x minus 1 squared plus 3. Okay, 2 times 2 is 4. Square root of 3 times square root of 3 is 3. 3 divided by 3, so those cancel. Over 2x minus 1 squared. 2x minus 1, 2x minus 1. So that's 4x squared minus 2x, that's minus 4x. Negative 1 times negative 1 is positive 1. So that's 4x squared minus 4x plus 1 plus 3. Okay, this was that, and there's my plus 3. So that gives me 4 over 4x squared minus 4x. 1 plus 3 is 4. Hey. Factor of 4 out. X squared minus x plus 1. Floors cancel, so that equals 1 over x squared minus x plus 1. And that, my friend, is the derivative of that, and it proves that our integral that we performed in a previous video was correct. Okay, the big key there, the constant multiple rule, we can bring the constant out, understanding that the tangent inverse of something in the parentheses equals theta. So if I'm looking for a derivative of all of that, that implies this situation here. Now that could have been, if that were sine inverse, cosine inverse, it implies something similar, okay? But that allowed me then to get d theta, plug that in, and then just factor things as necessary. Okay, why are we doing this? Together we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying, guys, and we'll talk to you next time. Thanks.